in 10C, we're figuring out if it's a field or not. So again, you need to look over your 11 field axioms. We're talking about positive numbers in this case. So 1 through whatever, or obviously anything, greater than 0. So if we take a look at closure, remember we want all parts must contain, in this case, we have positive numbers. All right? So if we take a look at this, and we have our addition and we have our multiplication, that's what the book is asking us to figure out if it's a field in those two sets. So what we're going to do is take a look at, add two positive numbers together and see if you get a positive number. So let's just say 2 plus 3 equals 5. Yep, and that's always going to be true. Multiplication, you have 2 times 3 equals 6. Positive, positive, positive. There we go, and that will always be the case. For commutative, remember, you just want to make sure, are they equal? That's what we're trying to figure out. So we have our addition and our multiplication. So we have, is 2 plus 3 the same as 3 plus 2? Yes. Multiplication. Is 2 times 3 the same as 3 times 2? Yes, it is. So we're good to go. For associative, again, you're just figuring out, are they equal? So if we have our addition, our multiplication, 2 plus 3 plus 4, is that the same as the quantity 2 plus 3 plus 4? Yes. For multiplication, 2 times the quantity 3 times 4, is that the same as the quantity 2 times 3 times 4? Yes. Now, for the identity element, remember it's really, really important that you just look at, or you consider that it's the element that we care about. So, if we have our addition, remember that identity, it's going to come back and equal itself. So if we have the number 2, 2 plus something is going to give itself, which is 2. So what's that number? Well, 0. So now, is 0 a positive number? That's the question you have to ask yourself. In this case, no, it's not. So XX, no, bad. Right there, that knocks it out. It cannot be a field because the identity element under addition does not work. Multiplication, let's keep going. 2 times something equals 2. Well, in this case, it's 1. Okay, is 1 a positive number? Obviously, yes. Yay, that works. Okay. Now, I know that since it's not a field, you would think that you could stop there, but I want you guys to actually keep going and try to figure out all the others because it'll help in other problems. All right, the inverse element. Again, element, that's what we care about. So if we have our addition, so inverse, we're looking at what undoes. So 2 plus something equals 0. It's always going to be 0 for the addition inverse. Well, 2 plus, this has to be negative 2. So again, ask yourself, is negative 2 a positive number? No, it's not. Bad. Okay, not going to work. With the multiplicative, here we go. 2 times something equals 1. 1 is always going to be for multiplication when you're talking about inverse. So we have 1/2. Is 1/2 a positive number? Yes. We're good. And again, you could be putting, you could start with any positive number here and you would get the same thing. And then last but not least, distributive. So we have 2 times the quantity 3 plus 4. Is that the same as 2 times 3 plus 2 times 4. Yes, it is. There we go. So we saw that no, it is not a field. Because we do not have an additive inverse or an additive identity. That is our answer right there. But of course you have to have the work to back it up. And that is the end of the problem.